All right, so on this unit, we're gonna start using and learning order of operations. These are like the vocabulary mastery stuff that you're gonna need to know and that we're gonna go over during this unit. Base. Okay, so when you see the word base in math, base is like the number with the exponent. So if I'm saying like 4 squared, that 4 is the base, and that little 2 at the top that we call square, that's the exponent. So this right here, that's the base. Okay, so when you see base of an exponent or base, they'll just write the word base. Base is talking about that number. Okay, the big number on the exponent. You could write that down if you want on the side. I'm going to be erasing these as I write stuff, but you could leave it there. The next number that you're going to see is bracket, or the next word is brackets. Brackets are like what we're going to use for parentheses, right? So there's different types of brackets, right? There's a parentheses ones, but when you see them broken down like this, when there's like a C and a backward C, those are brackets, okay? And we're going to treat those brackets the same thing like we're going to treat parentheses, okay? Composite numbers. Composite numbers are anything that is not prime, and you're going to learn about prime and all that in a little bit. Cube is when you are gonna say it's a 3D shape, or if you say it's a cube like to the third power. Same thing with cubed, right? Cube is present and that's past tense, but those are when you're saying it's to the third power. An exponent is when these right here, an exponent are those little numbers. You could be a 2, a 3, or 4. An exponent are those numbers up on top. Factor tree is a way to prime factorization. We're gonna learn how to do that today, or this week. Grouping symbols, those grouping symbols consist of parentheses that are like this, or those brackets, if you see brackets like this. Okay, so those are our grouping symbols. A numerical equation. A numerical equation is pretty simple. It's an equation like that, just with numbers, numerical. A new equation has an equal sign at the end. So it's telling you to solve it. So 2 plus 3 is telling you to solve an equation, is something like that. A numerical expression is just expressing what they want you to do. It's not going to have the equal sign. So the expression for this will just be the 2 plus 3. That's the expression. This is the equation. Equation sounds like equal. It's going to have an equal sign. Expression is just going to express what they want you to do. Order of operations, okay, that's what we're going to be learning, but this is the order of operations, and you're going to remember this from elementary school, but it is called PIMDAS, and some people remember it as please excuse my dear Aunt Sally, just to memorize the orders. But just remember when you write the M and the D and the A and the S for multiplying and dividing, they go next to each other because you do those two at the same time, and the same thing with addition and subtraction. Parentheses, those are those grouping symbols right here. Those are the ones that are just going to look like a C that is frontward and backwards. Prime factorization is when we're going to get any number. We're just going to find the prime factors of it. Remember, the word factor means to multiply. So we're just going to find all the multiples of that number. And we're going to use the factor tree to solve those prime factorizations. Prime numbers, those are the numbers that you can only divide by itself or one. The ones that you're going to have to remember, and I'm going to give it to you in the notes down here, but the ones you have to remember are 2, 3, 5, 7, 11, 13, 17, and then sometimes you're going to have to remember 19. But 2, 3, 5, 7, 11, 13, 17, those six right there, those are the most important ones. Are those seven? I mean, those are the most important ones that you're going to need to remember. That eighth one right here, sometimes when you get to like eighth grade, maybe ninth grade, you're going to have to know that one. But in sixth grade, these seven right here, those are your favorite ones. Okay, 2, 3, 5, 7, 11, 13, 17. 2, 3, 5, 7, 11, 13, 17. Say those a lot, and you're going to be able to memorize those. Square and squared are the same thing like cubed and cubed. Cube is a 3D shape. There's three numbers we're multiplying. That's why we put a 3 on top. Squared are 2D shapes because there's only two numbers, a base and a height. So squared is when you have a 2 as an exponent. Okay, so these are some of the words that we're going to be learning. Today, you're just going to figure out this graphic organizer. Um, but I'm going to erase this. Make sure you have all that stuff written down. If you need to, you could pause the video and write that stuff down. Okay. So now as I go down, you're going to see these graphic organizers right here. We're going to complete the first one for prime numbers. Okay. So the first one we're going to do is prime numbers. Now, when we talk about prime numbers, okay, we're going to have the definition. And I'm going to write the definition and then I'm going to read it. So definition is a whole number greater than 1 that cannot be exactly divided by any whole number other than 1 and itself, right? A whole number that is greater than 1 that cannot be divided by any other number other than itself and 1. And the examples for that are going to be those first ones that I told you need to remember. 2, 3, 5, 7, 11, 13, 17. And sometimes you're going to need to remember that 19. And there's a lot more, but these are the first ones that are very, very important, right? So 2, 3, 5, 7, 11, 13, 17, and 19. The only numbers you can multiply are 2, that number itself, and 1 to get that number. Like the only way I can get 2 is 2 times 1. There's no other two numbers I can multiply to get 2. Same thing with dividing, because dividing and multiplying are opposites of each other. They're fact families. To get a 3, the only way I could get a 3 is 3 times 1. There's no other number I could multiply by that's a whole number to get 3. 5. 5 times 1 is 5. There's no other numbers in between that I can multiply to get that 5. Okay. And it's the same thing for those, even when you get higher, like 13. 13 times 1 is 13, but there's no other numbers I can multiply those two numbers to get 13. Okay. So that's the big key of prime numbers. All right. So some facts about prime number. One fact is 2 is the only even prime number. Okay. 2 is the only even prime number. Now, 2 is the first prime number, right? And it's the only even one because that's the first one that we could do 1 times 2. Now, when you get to your next even number, which is 4, 4 times 1 is 4, but 2 times 2 is 4. Same thing with 6. 6 times 1 is 6. 2 times 3 is 6. Every other prime number, you're going to be able to use the number 2 to multiply something to get that even number, I mean. Okay. So the other fact that we're going to say that the number 1 and the number 0 are not prime. And a lot of people say, well, like, oh, sir, well, 2 times 1 is 2, 3 times 1 is 3, 5 times 1 is 5. There's only multiplying those numbers, but what about 1? 1 times 1 is 1. Yes, you're multiplying by 1, but notice that I'm using the 1 2 times. I'm saying 1 times 1. All of these, the 1 is only being said once. This one, I'm saying that twice. 0 is not a prime because remember right here, it says a whole number greater than 1. 0 is not a positive nor a neutral, positive nor a negative number. It's a neutral number. So 0 is not a positive prime, nor is it a composite number. Okay. So our non-examples are going to be 0 and 1 because those two cannot be prime. 1, you use it. You use 1 times 1, which is 2 ones, and 0 is not greater than 1. But then also any even numbers. So you could write even numbers greater than 2, right? And even numbers greater than 2 cannot be prime. Okay. So this is your kind of like your Venn diagram, your graphic organizers for prime numbers. Okay. And we're going to do that for the next one, which is composite numbers. Okay. So these are the two type of numbers that we have. We either have prime numbers, which are all the numbers that you can only multiply by 1 to get itself, or composite numbers. Now, definition of composite numbers is a positive integer. Remember, an integer is a whole number that can be divided by at least one positive integer other than 1 in itself. Right? So like the number 4. 4 could be divided by 4 divided by 1 is 4, And 4 could also be divided by 2, like 4 divided by 2 is 2. Or you could say 1 times 4 is 1 and 2 times 2 is 4. I mean, 1 times 4 is 4 and 2 times 2 is 4. There's two different ways I could get that number 4, right? So that 4 is a composite number. Okay. So some examples of product numbers are, like I say, any even number that's greater than 2. So you can say like 4, 6, 8, 10, 12, 14. Those are all composite numbers because they're all even numbers greater than 2. And the numbers that you can multiply by itself and a different number to get it. Okay, so such as 15. 15 is not an even number, but 15, I could get 15 two different ways. I could get 15 as 15 times 1, and I could also get 15 as 15 times 3. There's two different ways to get that answer 15, meaning I have more than two factors. My factors are 15, 1, and my other two factors are also 5 and 3. These all four factors are for 15. Okay, a prime number has to only have two factors, which is the number and 1. A composite numbers will have more than two factors. Okay. So facts, and that leads to fact into characteristics. Composite numbers will have more than two factors. Okay. That's the main thing. We'll have more than two factors. And that's other than 1 or outside of 1 and itself. Okay. And so non-examples are our prime numbers. These are prime numbers. So these are not examples of composite numbers. So 2, 3, 5, 7, 11, 13, 17, and 19. Or prime, any prime number is not a composite number. All right, so go ahead and pause this screen. Make sure you have all that written down. I'm going to erase this so I can move on to the bottom part. All right, so I'm gonna go ahead and scroll down, and you're gonna see two more. It's gonna be exponents and base, right? So first one we talk about exponents. Now exponents are the little number that are on top, right? But when we write a definition, the definition is going to be a number that tells you how many times to multiply the base by itself. Right? So an exponent is going to tell you how many times you multiply by its base by itself. Okay. For example, if I have 4 to the second power, 4 is my base, 2 is my exponent. That exponent is telling me to multiply the 4 two times. So it's not 4 times 2. That's wrong. This will actually equals 4 times 4. I used the 4 two times, which will equal 16. Okay. And this is true for as high as this exponent goes. Now in sixth grade, the highest you're going to see it go is maybe 3, maybe 4, but you will see 3, which will look like 4 to the third power, which does not mean 4 times 3. That is telling you you're going to use the base 3 times. So that is actually going to say 4 times 4 times 4. Okay. And do not notice how 4 times 4 was 16. Don't go 4, 8, 12 and say this is 12. That's just skip counting. That is not multiplying. Multiply 2 at a time like this. 4 times 4 is 16. Bring down that multiplying, bring down that 4 for that last one. And then you actually have to solve that 16 times 4, right? 6 times 4, 6, 12, 18, 24. 4 times 1 is 4, 5, 6. So 4 to the third power is actually 64. Okay, so please make sure that when you see an exponent, that exponent is not telling you to multiply the base by that exponent. It's not 4 to the third power does not mean 4 2 times 3. 4 to the third power means you're going to write that base 3 times. Okay, 4, 4, 4, and then you put a multiplying symbol between each one. Okay, so some of the facts on this are this exponent is always written as the top number. Okay, and the exponent will always be written up here on top, like a top number, and it is always used with this base. Okay, so it's always going to have a base in front of it. It's always going to have a base. Now, don't get me wrong, that base could change. It could be an equation, it could be something in parentheses, it could be a letter, but there's always going to have a base. You're never just going to have a random exponent floating there with nothing in front of it. Okay, so some of our non-examples, such as the 4 to the second power, it does not mean 4 times 2. No, this is wrong. Okay. And just like this, 4 to the third power does not mean 4 times through 2, 3. I mean, again, those two are wrong. These are not examples. The exponent does not mean to multiply your numbers by that. Okay. And then referring back to the exponent when we kept saying that word base, all right? Now, base, this is the number that is being multiplied by itself. Okay. So this is the big number, all right? B for big, B for base, right? So this is the number that's telling you how many times, what we're going to multiply by itself. Like over here, we say 4 to the second power. 4 was the base, meaning we're multiplying the 4 by itself 2 times. 4 to the third power, 4 was the base, meaning we're going to multiply 4 by itself 3 times. 4 times 4 times 4. Okay. And those are the same examples that we're going to do. Like 2 to the third power, that means 2 times 2 times 2. Right? If I said 6 to the second power, that is 6 times 6. Right? If I said 5 to the fourth power, that is 5 times 5 times 5 times 5. Okay. So notice that my base is not changing when I write this equation. That base is staying the same all the way through. That 4 is just telling me how many times I'm going to write it. That 6, that base stayed the same all the way through. That 2 just told me how many times to write it. Okay. So some characteristics is that B for base, and then B for the big number. That's what I used to say when I was younger. B for base, B for the big number, right? But it is always the larger number. And when I say larger number, I don't mean larger number like in the size that it's written. I mean larger number like in the I mean, when I say large number, I don't mean the value. I mean how the size that it's written, right? 3 is bigger than 2, but it's actually the 2's written bigger than the 3. That's going to be that big number, that base number. Okay, the main number stands out to you. And some non-examples, right, is you will not see a base number like this, right? The 3 is not the base number, right? The 2 is the base number. I don't know how to give you a not example, right? I guess you could say 4 to the 3. That right there is not the base. This is the base. Okay, so just make sure you have all this stuff written down. Make sure that you answer the questions correctly on the ad puzzle. And that's it. Thank you.